Since highway maintenance crews use a variety of types and sizes of vehicles, the next phase of the attenuator crash testing program would utilize a pickup-mounted attenuator. Testing of a lightweight pickup-mounted attenuator was desired because of the maneuverability of a pickup in congested traffic or on narrow roadways. 3 tests were conducted. The first test used a pickup without an attenuator. The purpose of this severe test was to provide a comparison with later tests where a lightweight attenuator was used. In the second test, the pickup was outfitted with an attenuator and was impacted by a heavy car. The purpose of the third test was to evaluate the lightweight attenuator after being struck by a lightweight car. In each test, a test dummy was placed in the pickup driver's seat and was restrained with a lap belt. All cars were self-propelled, kept on line with a cable guidance system, and released a few feet before impact. A speed control device on the cars maintained the desired impact speed. The construction method for the pickup-mounted attenuator is the same as the truck-mounted attenuator, except it is smaller. It is 6 feet 4 inches wide by 5 feet 6 inches long and 2 feet high. It contains the same formation of hex cell blocks for energy absorption. The rotation device enables the pickup to maneuver better in traffic, and the pickup can then be used for some normal duties. The first test, Test 391, used a 1972 AMC Matador weighing 4,290 pounds, excluding the test dummy, and a 1970 Chevrolet 3/4 ton pickup weighing 4,415 pounds, excluding the dummy. The pickup was parked with emergency brakes on and the transmission in neutral. The car impacted the pickup at 43.9 miles per hour on center. The ignition was cut off just before impact. The front of the car submarined under the pickup and struck the rear axle housing. This caused the axle housing to move forward and released the emergency brake, allowing the pickup to roll uncontrolled for about 300 feet. The pickup was severely damaged and could not be driven away as the rear bumper was completely severed from the vehicle. The rear portion of the bed was crushed, the rear axle housing was moved forward about 4 inches, and there was extensive damage to the drivetrain. The car grille was crushed back approximately 12 inches. The front doors were jammed slightly but easily opened, and there was no intrusion of debris inside the passenger compartment. The second test, number 392, was with a pickup outfitted with an attenuator weighing 150 pounds. The combined weight of the pickup and the attenuator was 5,000 pounds. The car was a 1972 AMC Matador weighing 4,310 pounds, excluding the dummy. To re-emphasize, the purpose of this test was to evaluate the lightweight attenuator impacted by a heavy car. The car struck the attenuator at the desired speed of 45 miles per hour, on center line and at the correct angle. There was little movement of the truck, while the car crushed the attenuator and penetrated it about 5 feet. Once the car bottomed out against the front of the attenuator, the pickup rolled ahead 79 feet and 5 feet to the left of center line. The car rolled ahead approximately 83 feet and 5 feet to the left of center line. The attenuator was crushed about 5 feet, and there was no damage to the attenuator hardware or the pickup. The car grille was crushed back about 7 inches. The front doors were jammed slightly but easily opened, and there was no intrusion of parts inside the passenger compartment in this successful test with the heavy car. The purpose of the final test, number 393, was to evaluate the lightweight attenuator impacted by a small car. The car was a 1979 Honda Civic, weighing 1,820 pounds. The car struck the attenuator at 44.8 miles per hour on center line and at the 0-degree angle. The pickup moved very little as the car penetrated the attenuator. When the car struck the back of the pickup, they both went forward, the pickup going 25 feet on center line and the car going 27 feet and turning 10 degrees to the left. The car grille was crushed back approximately 8 inches. The front doors were not jammed and there was no intrusion of parts inside the passenger compartment. The dummy had no lap or shoulder belt on. In later tests, lap and shoulder belts were required. The attenuator was crushed about 60%. The pickup and hardware were not damaged. This successful series of crash tests with the lightweight pickup-mounted attenuator proved that this device could be capable of softening impacts with small and heavy cars during rear-end collisions. The occupant impacts were less severe and the damage to the vehicles was dramatically decreased. It was concluded that the lightweight pickup-mounted attenuator could be considered for a shadow vehicle or lookout vehicle during a slow-moving highway maintenance operation wishing to improve the safety of workers and the traveling public.